If you're trying to choose between SYSWELD and Abaqus for welding simulation, this video will save you hours of confusion. In the next few minutes, I'll compare both tools in terms of modeling workflow, material definition, welding parameters, user friendliness, accuracy, heat source setup, and post-processing, so you know exactly when to use which software. Are you ready? Let's get started. SYSWELD versus Abaqus, the real welding comparison. Okay, let's start with the general overview of both software, starting with Abaqus. Abaqus is a general finite element software. It doesn't have any welding simulation interface. So you need to create the part yourself, you need to create material property, assemble the model, go to the step, create the interactions, load and boundary conditions, mesh, and create a job and view the job in the visualization module. So the good thing about Abaqus is you have everything in one software. Don't need to switch between different modules in different software. So you have everything in one general software. But let's go and take a look at SYSWELD. So in order to have SYSWELD, you need to have one visual environment, and on top of that you need to have the license to take care of the welding simulation for you. So here we have welding and assembly, and in welding and assembly you can select mesh, visual weld and visual viewer, and if you click on OK, it will take you to the software. It takes time, but as you see here, we are in visual weld, but you can change the applications to visual mesh, visual viewer. In each module, you have different things to do. For instance, here in visual mesh, you can create your model. We'll come back to the model creation later, but as we are here, we know that we have to create our model geometry in visual mesh. And after we created the model and mesh the model, we can go to visual weld, and here we have the materials database, and we can create the path of welding, and after that we can go and select the welding parameters here in visual weld. And after the welding was done and the simulation was over, we can go to visual viewer to take a look at the results. So the concept is similar, but we have different modules in basically different software. So each one of these modules are different software. So we have one for visual mesh, one for visual weld, and one for visual viewer, but basically it's similar. Now let's compare Abaqus and SYSWELD in terms of model creation. So in Abaqus, model creation is not really hard. So if we want to create a plate, we can go for 3D deformable solid extrusion and we continue. Let's say if we want to create a plate, we can create a plate just like this. Then we can assign the thickness, for instance 10 millimeter here, and we have this one 60 millimeter, and let's say we want to have the depth of like 100 millimeters. And as you see here, we have a plate 10 by 60 by 100. Easy as that, we can create a plate. But let's do that in SYSWELD. How can we do that in SYSWELD? First, we need to go to visual mesh. Here we are in XY data. So here we can go to node by XYZ locate. We have to create 4 different coordinates. So the first one, if we assume that it's on 0, 0, we should create the model in a 2D. So this is Y and this is X. We can have 0, 0. Then we can have 60 and 0. Then we can have 10 and 60. And we can have 0 and 10. And now if I zoom out a little, as you see, we have 4 different coordinates. Now we have to go to 2D, and here we should select 3.4 mesh. And here we should select the points. So this is 1 point, this is a second, third, and fourth, and we have to mesh it. So in SYSWELD, we create the model and we mesh that at the same time. So here I can modify this here Or here, if I want to make it better and I say create a mesh, the mesh is not really good, but it's just an example and it's not over yet. Now I need to extrude this part. To do so, I can go to 3D and I can select sweep and drag. Here we select. After we select them, we should click on this one in order to select them. And now for standard axis, we can select Z axis. And as you see here, it's going to extrude it, sweep it through this direction. We click OK. The distance is 100 already. And if we click on mesh, here we have the mesh, and here we need to apply some sort of things. If we take a look at the mesh and click on OK, we have the mesh, and let's make it solid. And as you see here, we have our part. It is like too much hassle to create one part. We have to create one part, then we need to sweep it. The good thing is we mesh that at the same time, but some parts are really hard to create and modify. So I think I give the convenience point in model creation to Abaqus. But SYSWELD has one advantage. If you go to welding utilities, you have a spot weld mesh. So instead of creating the model manually, you have this electrode top and you can create the model directly. So you need to set a working directory. Then you have sheet 1 and sheet 2. This is literally the number of sheets. You can have 1, 2, up to 4, and you write the thickness here. You input the values of electrode curvature, radius, height, and everything. Then create the mesh. It takes a while. Then it creates 2 sheets for you here on top of each other and 2 electrodes. You can modify the mesh, or you can go to welding utilities. You can have HSF mesh, and here we have different things like butt joint, lap joint, overlap joint, different things here, and T-joint without bead. You can input the values, simply thickness, half width, thickness for component 2, and everything else. Then you can create a 2D mesh, and after that you have the model ready for you. In this case, it's way easier to create a model in SYSWELD, but Abaqus is easier to deal with, so it's up to you to select SYSWELD or Abaqus. For material properties, you need to input them manually in Abaqus. So in Abaqus, you need to create, for instance, conductivity, density, and specific heat, and you need to input them as temperature dependent material properties. If you want to do the residual stress, you need to input some other things like mechanical expansion or plasticity and plastic, and you need to use the temperature dependent data. It's a hassle to find the materials properties for the specific alloy you want, but in SYSWELD, let's see how it works. If you go to database and material, here you have a huge material database for aluminum alloys like 5000 series, 6000 series, or you have nickel alloys, you have low alloy carbon steels. Let's select one of them here, like this one, which is ST52. You have different things here. You have phase information, you know about the phases like ferrite, martensite, bainite, or austenite. If you want to do that in Abaqus, you need to write codes for that. You have thermophysical material properties here. For instance, you have thermal conductivity, temperature dependent data. If you click on this, you have the charts here. You also have mechanical properties here, Poisson's ratio or Young's modulus. If you want to perform the residual stresses, they are pretty crucial. And the good thing here is they have it based on different phases you have in your material. So if you select low alloy carbon steels, you have Young's modulus temperature dependent data based on ferrite, martensite, bainite, or temper martensite and austenite, which is pretty cool. You have different alloys here, and you can create your own material properties if you want. So here we give the point to SYSWELD in terms of material properties because it has a very good material properties database. Now for welding setup, In Abaqus, you have to create this step. First, you need to create a step here. Then you need to create the interaction. So we have different interactions here, like surface radiation, or you can have surface film condition here. You can input the values. You have to input them yourself. Then we need to create the load. Abaqus doesn't come with welding, thermal loading, so you need to create heat flux, and you should write the subroutine code. So if it's arc model, you need to write a DFLUX subroutine for Goldach model, or if it is laser based, you need to create a Gaussian distribution model. I already have so many videos on that. Go ahead and check them here on top right. I show you one subroutine example. So you need to create XYZ and time. Then we need to input the value of V, torch speed, we have the input power, we have the radius of heat source, then we have the moving heat source. If it's Gaussian distribution, so you have the heat flux here, you have the equation, and this is the code you need to write. So dealing with code is kind of hard. I don't want to do that. If you don't want to create the load just like that, the only option you have here is, for instance, surface heat flux. If you create surface heat flux, and if you want to create the uniform load, you should input the magnitude here, but you need to create different parts, different steps, so that the flux moves. Otherwise you don't have any option, so you need to stick with DFLUX coding. And the coding language that works with Abaqus is Fortran. Fortran is one of the oldest coding languages, so it's really hard to write a code if you don't have the knowledge. But in SYSWELD, it's a whole complete different scenario. You should create the welding path here. So I already created the welding path. It's really easy. If you go to welding utility and the trajectory, you basically need to select the first point, last point, and the reference point so that it creates the welding line for you. After that, you need to go to advisor and welding advisor. Let's start with this one. First, you need to create a job. Then you can assign the material properties. And here we have the weld parameters. So it's really easy. You need to select the weld line you created before. And in weld pool, you can write the units. In Abaqus, you don't have any units, so you have to be consistent with the units. But here you can select the units. You have joule over millimeter, or centimeter, or kilojoule over centimeter, and the velocity. You have three options as can be seen. And here we have the arc for the heat source, and we have different things, but we selected general arc here. You can select the process type. If you select laser, it will be beam, so we don't want to do that. Let's stick to general arc. Here we have the velocity, initial time, end time, and we have the length, width, and penetration, which is associated to the Goldach double ellipsoid. You can also see the ellipsoid here, which is pretty cool, and it's not in Abaqus. So you have an estimation of the penetration, width, and the length of the Goldach ellipsoid. And here in the energy, you can input the energy here, the efficiency, power ratio, and the length. So it is way easier to set the parameters here in SYSWELD compared to Abaqus. We have the cooling conditions, and here we have the clamping definition. So we created the clamping conditions here. It's also easier compared to Abaqus. Then you can go and solve the model. To compare the accuracy, both of the software are pretty accurate. So there are so many companies using SYSWELD or Abaqus in their projects. I mean, very big companies like car manufacturing companies, and those software are reliable. Last but not least is the post-processing. Here in Abaqus, we have post-processing. We can plot the contour here. You can see the animation here if you want. This is the laser moving here. You can also change that here from option command, and you can remove the meshes to see the laser better. If you want to plot a contour here, you can go to ODB field output, continue, and here you can select unique nodal temperature, and here you can select the node and you can plot it, which is pretty easy. You have temperature versus time, and here you can have access to your plot. So XY plot, you have chart, you have XY data here. If you click on edit, you can get access to the results so that you can copy and paste them in Excel, Origin, or wherever you feel confident to work with. But let's go here. You can plot the contour. So in contour option, you have different things here. If you want to take a look at the temperature, you have temperature node, and here you can hit the play, and as you see, it moves. I don't like the animation here, so the plot contour in Abaqus looks more beautiful, but it doesn't matter that much, I think. But the good thing is here we have phase analysis. So in welding, it's really important to know that the welding parameters were good or not. Like this one, this is a lap joint. If I go for phases, we know that phase 2 is the filler material. And after the welding was completed, you can see the proportion of the filler material. So this is very low, but if this number is high, you know that you have remained an unmelted filler material. You can check the austenite or other phases here. It's pretty cool to see that during the welding simulation, and this is something that Abaqus doesn't have. And if you want to perform phase analysis in Abaqus, you have to write complex codes. Now let's say if you want to plot something here, this is temperature node, and you have to go to the file, import and plot. Here you see temperature node. You can select this node, for instance, and plot it. It's literally the same thing, same as Abaqus. You can go to the tools, you can save the image if you want, or if you want, you can export the curves. It gives you a CSV file, and you can use it in Excel, Origin, or other software. So to wrap things up, Abaqus is a general finite element software. There is no welding module. You have to input everything manually, including materials properties, loading, and everything else. And if you want to have accurate welding simulation, you need to write subroutines, which is encoding and is kind of hard for some people. But SYSWELD is a software fully tailored for welding simulation. It comes with a huge built-in material database, and you can define all your welding parameters without writing a single line of code. It also offers phase transformation analysis, which is a big advantage if you're working with steels or alloys where metallurgy matters. The downside is the modeling. Creating your own custom geometry can be a bit difficult, because SYSWELD often expects you to build models using coordinates. However, for common welding configurations like T-joints, lap joints, butt joints, and other standard setups, SYSWELD provides predefined templates that make the modeling process much easier. And that's the full comparison between SYSWELD and Abaqus for welding simulation. Let me know in the comments which one do you use for your welding projects, SYSWELD or Abaqus. If you're using SYSWELD, click the video on the right hand side to dive deeper into advanced welding simulations. And if you want to continue with Abaqus, click the video on the left. I'll take you step by step through welding in Abaqus as well. Thanks for watching, and I'll see you in the next one.